Welcome everyone to today's webinar. My name is Jody Wadwa. I'm the VP of Marketing with AppScan. Today's webinar is titled End-to-End Mobile Application Security, Build It Secure and Keep It Secure with IBM AppScan and AppScan. We have two mobile security experts with us today that will guide us through our discussion on mobile security. Before introducing them, I'll ask the audience members to use their chat utility at the bottom of their screens for any questions that will be answered at the end of the webinar. I'd like to now first introduce you to our first speaker. His name is Tom Mulville, Senior Product Manager with IBM Security Systems. Our second speaker is Jonathan Carter, Technical Director with AppScan Technologies. Jonathan, can I please ask you to lead our discussion today?
Sure. Thanks for having us and hosting the webinar. So during today's talk, we're really going to be talking about, we're going to be doing some risk education and awareness. So as part of Agenda Point 1, we'll be speaking about, risks associated with mobile computing. And we'll also be talking about how to protect your applications from an application security perspective using AppScan, and then keeping it secure using AppScan. The first question that a lot of people have when they talk about the problems of cracking applications and reverse engineering, they first want to know, how bad actually is this problem? How often are people actually taking mobile applications, cracking them, changing the code, redistributing them to do all sorts of interesting and unusual things? And unfortunately, the answer is extremely common, and this is very, very widespread within today's market. AppScan did its own, independent study in 2012 titled Mobile Apps Under Attack, in which we looked at the top 100 paid and unpaid applications for both Apple iOS and Android. And we really wanted to know, how many of these applications could we actually find on various third-party sites which were available for free to a potential victim? And unfortunately, the answer is that, in the case of Android, when you look, you see that it's 100% of the top 100 paid and 80% of the free applications for Android were available on various third-party, sort of nefarious sites where you could get stuff for free. And the prospects aren't very, rosy when it comes to Apple iOS either. In Apple iOS, we saw 92% hacking. 92% of applications were exposed. For paid, and for unpaid, it was 40%. And in those cases, what we often saw was applications which were distributed for free, quote unquote, and 80-some-odd% of the time, an attacker had inserted spyware or malware into these applications. When we look at what are the types of things that we need to worry about from an application security perspective, the first line of defense when we're trying to prevent somebody from modifying an application is static analysis. So we use tools like AppScan in order to review source code using things like taint analysis and pattern matching to identify common vulnerabilities that a software engineer can control and fix. So we can correct that during the development time using static analysis. At runtime, we have other tools at our disposal in order to prevent application security vulnerabilities from being exploited by things like web application firewalls, be an example of a runtime analysis or a dynamic analysis. Now, we really need to start worrying about integrity protection when we're hosting our code in an unsafe environment in which the adversary has physical access to the code, and they can, in fact, undo all of the great things we've done using static code analysis techniques. Through static analysis, dynamic analysis, and hybrid analysis, where we're able to do, pen testing, we're able to correct for code deficiencies. Unfortunately, in the case of integrity protection, the adversary can undo all of those things that we've fixed through these various scanning techniques because they have access to the code. Using guard networks, our applications should be able to defend against integrity violation or reverse engineering. They should be able to detect application attacks at runtime when somebody is inspecting and trying to modify the application. And they should be able to intelligently respond and react to those actual attacks and throw the attacker off. I'm going to hand it over to Tom now to talk more about specific application security risks in the user environment versus enterprise environment.
Great. Thank you very much, Jonathan. To kick things off, I'd really like to make a distinction here between the risk associated with mobile malware and mobile application security between the user and the enterprise. We are obviously focusing on trying to help enterprises protect their mobile applications. However, the users are affected as well. We all know, love, care for users. We are users. What's the threat to the users? Well, the threat is really from Trojans and from spyware, malware. How does it get on the user device? Typically, phishing attacks or spear phishing attacks is very prevalent to have malware bundled with valid applications that are made available on Android marketplaces. So that's a major source of introducing risk and malware to the user devices. And what happens? Well, it's the obvious things. Unauthorized use of all these device-specific capabilities. Maybe the malware will send expensive text messages or place phone calls expensively without the user's knowledge, disclose public information. But really, the risk, too, is to the data on the device. That's both the user data and the enterprise data that's on that device. The malware is going to mine for interesting information and send it back to the hacker, which is our connection to and our segue to the risk from the enterprise perspective. So what is the risk from the enterprise? It's really all about data leakage. What's happening is the malware is indiscriminately looking for information on the mobile device, collecting that information, which could be corporate information, and sending it back to the hacker. And why is this a problem? Well, for a couple reasons. One is hackers have very easy access to these applications, so they're very easy to gain access to. They're not expensive. It's easy for them with the tools they have at their disposal, and Jonathan will explain this in more detail. In fact, provide an example of this in a minute on how easy it is to reverse engineer these applications. And from an enterprise perspective, there's no or little application control. In a world where employees bring their own device, or even in the consumer world, say you're a financial institution providing your applications to consumers, you have no control over the applications that are installed on the mobile devices. And for this reason, OWASP, which is the Open Web Application Security Project, has identified insecure data storage as the #1 mobile application security risk. Next slide, please. And here's a little or some additional information on the OWASP Mobile Top 10 risks. It's in release candidate form now. It's still being worked and refined. And this parallels some of the work OWASP did focusing for years now on the risk for web-based applications. And you can see that there's a risk there associated with insecure data storage. Next slide, please. The way IBM addresses this challenge is with our AppScan portfolio of products, specifically AppScan Source for Mobile. What we do is we ensure mobile applications are not susceptible to malware. We're not going to identify the malware. We're not going to eliminate the malware. We're going to make sure that you develop secure applications that are not susceptible to malware. We support Android and iOS native applications. We have done extensive security research on the native SDKs, understanding the security risk and profile of over 40,000 mobile OS APIs. We support Mac, the Mac platform, Xcode. We have full data and call flow analysis. It's one of our key capabilities for the languages we support. So you know exactly where data enters your application, what it touches inside your application, and where it leaves your application. Effectively being able or providing you the ability to identify where sensitive data is being leaked. Next slide, please. So AppScan does help identify data leakage. Here is a listing of 3 of the OWASP Mobile Top 10 security risks: insecure data storage, side channel data leakage, and sensitive information disclosure. These are all challenges. So data leakage really is more than one thing. Collectively, these can all be considered types of data leakage. And the benefits for AppScan and using AppScan source, as I highlighted earlier, is we have complete knowledge of where the data enters your application, what it touches inside your application and where it leaves. We can effectively provide you an encryption map. So wherever data leaves your application, depending upon the sensitivity of that information, you need to encrypt that information. And really, that's the segue and the connection to and the value of the combined AppScan and ArcScan solution. So through the use of AppScan, we're going to more easily help the ArcScan product owners and users identify what to protect in their applications. Now I'm going to turn it back over to Jonathan to discuss application integrity in more detail. Jonathan?
Thanks. It's a perfect segue because, our particular product helps users of AppScan essentially make sure that they're plugging the information leaks and keeping those leaks fixed. So let's look a bit more at the actual problem itself. Essentially, an attacker can have physical access to the sensitive code. As such, they are perfectly able to open and analyze that actual code using decompilers and disassemblers on jailbroken or rooted devices. Once they're analyzing the code through static code analysis tools such as IDA Pro, for instance, they understand the control flow. They can then modify the control flow, repackage, and send it out again for execution by their victims. We can essentially undo any code correct features which have been implemented correctly through the use of AppScan if the attacker has physical access to the code. And here are some examples of typical types of attacks that we see. As mentioned earlier, we see a lot of attackers, taking applications and modifying security controls and disabling security controls within the application in order to, get access to some more interesting things like data encryption or decryption keys. Once they have access to these keys, they can then decrypt sensitive data that's sitting on the device and steal all sorts of personally identifiable information or privacy-related data. The other common thing that we saw in our studies, North Carolina State University also did its own study. They had found a massive number of applications available that were free, which had various adware features disabled, but they had inserted spyware and malware into the application. So once again, steal this information off of the user's phone. Using ArcScan application integrity protection technologies, we're able to essentially take an application provided by an organization which has already run through static code analysis tools and essentially make it self-defending against reverse engineering attacks and integrity violations. And we do this using something called a guarding technology. And these guarding technologies allow us to essentially disable an attacker or keep the attacker from understanding the code through reverse engineering analysis. So that's the defense component of it. At runtime, the applications are also able to detect that an attacker is making that modification. And at runtime, the guards are then able to react accordingly in order to thwart the actual attack itself or to frustrate the attacker. And here are some examples of some of the types of guards that we have available. So for instance, when we talk about defense guards, really we're talking about some of the more classic things that people think about when they think about reverse engineering prevention. code obfuscation, for instance, in which we do instruction block chopping, instruction substitution, symbol shuffling, and many other techniques just within the code obfuscation guard. We have other more interesting guards within our defense capabilities where we can do things like provide encryption, where we encrypt sensitive code sitting within the file that represents your binary image. We can also do things like strip method symbols and data symbols, which are exposed within these final binary packages. These symbols represent particularly useful information to an attacker who wishes to understand the control flow and modify it accordingly. Once again, at runtime, we're able to take an application, and the application, which is protected using our guard, is able to detect successfully that it's running in a jailbroken environment, and in which case it can choose not to honor the transactions or disable itself. We also have things like resource verifications, checksumming, where we're able to inspect the code and make sure that the code matches what we expected at build time when the guards were inserted. And we have more sophisticated guards as well. So for instance, with iPhone-specific guarding technologies like swizzling detection, we're able to prevent both internal swizzling and external swizzling from an iOS application. In swizzling, the attacker is essentially trying to intercept API calls and change the behavior of the application without changing the actual binary itself. It's a more sophisticated attack, but it's very effective and very easy to do nowadays with tools such as mobile substrates. Our strength within this particular product line is not only the guards themselves, but the multi-layered guard approach, where we basically have defense in depth, where guards are protecting not only the code, but they're also protecting each other. So when we look at how we fit into the overall software development lifecycle, you can see that during the vulnerability analysis and testing stage, IBM AppScan is useful for doing source code analysis. During the application protection stage, which happens just before release, ArcScan is then able to harden the application. So let's actually look at a demonstration of the technologies where we see both products working together. This particular video, we're going to show you how to conduct a reverse engineering attack against our particular application that we wrote as a proof of concept. So this is a banking demo application which allows the user to submit financial transaction data and talk to a backend. This is the backend server here, and this is the client on the front end to the left. So you can see that the user is now trying to log into the proof of concept server in order to conduct a financial transaction. And we're trying to represent what banking applications typically do. When a banking application typically starts up, it will try to successfully detect that it is running in a hostile or jailbroken environment, in which case it may choose not to honor the transaction or feed it in as a risk. So we can see here that when we're actually running the application on a jailbroken environment, the code is behaving correctly. This is doing what most applications will do correctly. But as an attacker, we want to be able to disable this feature so that we can run this code within a hostile environment and do much more interesting stuff. Here is an example of the source code behind our actual jailbreak detection algorithm, where we're looking for things within the environment to verify that it is jailbroken. And we're going to show you how to disable this code without needing access to the source code. So first, we need to examine the actual binary, modify it, and then repackage it. Through examination, we're going to take the application which has been decrypted using Clutch, and we're going to feed it into a tool that we have. It's very easy to get, and everybody can use this tool quite effectively. We're going to first look for jailbreak detection code. And believe it or not, this is extremely simple. We look at the method symbols to actually identify the code where jailbreak detection is occurring. And believe it or not, this is very, very straightforward and simple, and it's very effective in most cases. And you'll notice how the method is exposed directly in the binary. There's been no protection at all of what it's actually doing. So you can now examine the actual binary for that particular method and find the actual control flow and get a fairly high-level understanding of what the code is doing. And here you can see we're just doing a simple branch statement where we're trying to detect whether or not the method is running in a jailbroken environment. And we're going to make a very simple instruction substitution to disable this branching and always force the application to return a not in jailbroken status. And that's it. It's only 2 bytes of a change. Very simple. We're now going to verify that the 2 bytes that we changed do in fact disable the jailbreak detection security control effectively. So we've modified our application, we've re-signed it, we've redistributed it on our phone, and now you can see that when we're actually doing our financial transactions, the application no longer reports that it's running on a jailbroken device. So we've succeeded in terms of our crack. What we wanted to know next was what could we do with AppScan to try and identify this particular issue? We rescanned the application using AppScan Source for Analysis version 8.7, and we can see that it identifies classic application security vulnerabilities, but it doesn't identify the integrity risk which we were able to successfully exploit. Within ArcScan, we actually wrote a custom set of rules in a rule pack that allow you to identify particular points within the source code where an attacker may in fact be interested in doing damage to your code, modifying the code, injecting code, et cetera, et cetera. So we rescanned this same application using our new rule pack to see what types of issues the application or AppScan could now identify. And now you can see it identifies 12 vulnerabilities within the application where an attacker will be particularly interested in conducting an attack from an integrity risk perspective and violating the integrity. You can see it reports on things like weak jailbreak detection algorithms, particularly attractive methods that would be useful for an attacker to intercept when they're trying to reverse engineer or violate the integrity. Using the multi-layer guard network, level 1 checks and inspects the actual code itself. These are the guards that we were referring to earlier. Levels 2 to 5 then refer to guards which protect the guards below them. So in this particular example, you can see that a level 2 checksum guard is protecting other guards available here, such as other checksum guards and repair guards, which are protecting level 1. So we can make it particularly painful for an attacker to violate the actual code because they not only have to violate the first level, but all other levels as well. In our example, we then protected the application using ArcScan technologies, and we're once again going to try and reattack the application, which has been hardened using ArcScan technologies, and the issues have been addressed and mitigated and identified using AppScan technologies. And here we're doing the same as we did before, where we're issuing a balancing request. And once again, we now see that although we applied the same binary change as we did before, the application is able to successfully thwart the attack and not allow the attacker to successfully modify the application. So we've succeeded in mitigating this specific risk through the use of AppScan as well as ArcScan. So let's switch back to the actual video itself, or to the presentation, and continue on. When we look at how these two products work together, there are a number of different things that we have built and distributed for consumers of ArcScan and AppScan. So we have a technical guide which shows you how to integrate both into the SDLC. We also have the IBM AppScan rules, which we are publishing, which allow customers of AppScan to scan and actually see the integrity risks which we've highlighted today. These rules allow us to identify, which particular protection tools you should be using within ArcScan. So we can provide recommendations around guards that you should be using. And all of these solution components have been tested and validated to ensure interoperability between both technologies. We have an example here of a particular customer of ArcScan's who was a CIO of a Fortune 500. They were coming into the organization. The organization had a history of application security problems, and they basically wanted to drive innovation into the mobile application space. And at the same time, they needed to address the security concerns raised by their security experts internally. Security experts internally were worried about reverse engineering. They were worried about exposing some of their sensitive code on these mobile devices. So with the help of ArcScan, we were able to not only mitigate these particular risks raised by the security internal folks, we were also able to help the CIO win the CIO 100 Award for Innovation. In summary, you need to augment your code testing with proactive protections inside your mobile application. And you can do that using IBM, AppScan, and ArcScan together. So IBM AppScan helps you build your application securely. ArcScan keeps it secure and allows you to have applications which are self-defending against attacks. At the same time, these applications can also alert and respond intelligently to these types of integrity or reverse engineering attacks. So the next step, you can request a free evaluation or proof of concept for your enterprise. You can also get a solution brief and demo video from ArcScan or IBM. And if you'd like more information about the rules that we wrote, you can go to the IBM Partner World, IBM Developer Works as well. That's it for us. You can contact me, Jonathan Carter, at arcsan.com. Tom, would you like to say a few words?
Sure, absolutely. First and foremost, Jonathan, thank you and the ArcScan team for putting together a wonderful presentation and demonstration highlighting the value of both ArcScan and AppScan being used together to truly protect customers' mobile applications. Yes, everyone, if you're listening to this, feel free to reach me here at my IBM email address. That's tommulvihill@us.ibm.com. And we look forward to ongoing collaboration and partnership with ArcScan. Thank you very much.
Thanks.